Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 12B. I'm Pranjal Banage, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on 24th February in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentations and 3 minutes for questions and answers. In 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Now, before we start the session, I would like to introduce you all to the session chairs of this session. Dr. Poonam Relkar is an associate professor in the Department of Computer Engineering at STES Kashibai Navle College of Engineering, Pune, India. She has published over 30 papers in national and international journals and conferences and has authored a book. Her research interests include the Internet of Things, machine learning, security, and database management system applications. Next, I would like to move on to our next session chair of this session, Dr. Lakshmi. She's an assistant professor in the Department of Information Technology and Management at Guru Nanak College in India. With strong interests in machine learning and practical IT applications, her research work focuses on the application of data classification and machine learning techniques, particularly in the development of predictive and classification models for heart disease and analysis. Ma'am, I would like to invite you to give some opening remarks.
Good morning, everyone. Can you hear me, voice, ma'am?
Yes, ma'am, you're audible.
It is my pleasure to welcome you all to this session. I am honored to serve as the session chair for today's presentation. This session focuses on information and communication technology. We have a series of interesting and insightful presentations lined up, and I am confident that they will provide valuable knowledge and meaningful discussion. Before we begin, I would like to briefly mention the session guidelines. Each presenter will have 12 minutes for presentation. This will be followed by 3 minutes for questions and discussion. Let us maintain a respectful and engaging environment throughout the session. Now, without further delay, I would like to invite our first presenter to deliver their presentation. Thank you. Let us begin the session. Thank you.
I would like to add into ma'am's introduction and invite Miguel Bone to present his paper on a brief review on explainability in deep learning for brain tumor segmentation using a systematic approach to topic discovery through neural embedding. You may present your paper by sharing your screen.
My name is Miguel Bon, and I'm here on behalf of my co-authors, Remigio Hurtado, Roberto Romero, and Henry Takuri from Universidad Politécnica Salesiana in Cuenca, Ecuador. Our paper is titled A Brief Review on Explainability in Deep Learning for Brain Tumor Segmentation, using a systematic approach to topic discovery through neural embedding. So, in the next 10 minutes, I will show you how we use a neural topic model to systematically review 156 papers and what we found about the critical role of explainability in clinical adoption. Here is the structure of my presentation. I will cover the introduction, problem statement, methodology, results, and conclusions. Let me start with some context. Brain tumor segmentation using MRI is one of the most critical tasks in neuro-oncology. When a radiologist examines a scan, they need to determine exactly where the tumor ends and healthy tissues begin. This boundary directly affects the treatment planning. During surgery, cutting too little leaves malignant cells behind. Cutting too much can damage essential brain regions. Now, deep learning has made remarkable progress in this area. Models based on UNIT and transformer architectures now achieve DICE scores above 0.92 on benchmark datasets. These numbers are impressive. However, and this is the key point, accuracy alone is not enough. In high stakes medical decisions, clinicians need to understand why the model drew a particular boundary. Without this transparency, they cannot trust the tool. This is where explainable AI or ICICT become essential. So, what exactly is the problem? First, the black box dilemma. Despite their high performance, deep learning models are opaque. When a model segments a tumor, it provides no explanation for its decisions. The radiologist sees the result but cannot understand the reasoning behind it. Second, there is a clinical adoption gap. Multiple studies report that radiologists express significant mistrust when they cannot verify the logic behind AI predictions. This is especially critical during surgical planning and radiotherapy. And third, regulatory pressure is increasing. Both the FDA in the United States and the CE marking system in Europe now require the algorithmic transparency. They demand what is called the right to explanation before any medical tool can be deployed clinically. Now, the research objectives. Given this challenge, our research has three main objectives. Objective one, systemize the literature. We use a neural topic model approach called ECRTM to analyze 156 peer-reviewed articles published between 2020 and 2025. Objective 2, evaluate XAI utility. We document the clinical effectiveness of explainability methods such as GREDChem and SHAP in brain tumor detection. Objective 3, quantify the performance gap. We analyze the disparity between benchmark results and real-world clinical data, finding 5 to 10% decrease in accuracy. Now, let me explain how we conduct this review. This is one of the main contributions of our work. Traditional systematic reviews rely on keyword search, which only find documents that share exact terms. Our approach is fundamentally different. We employ the embedding currents regularized topic model, or ECRTM. This model combines variational autoencoders with semantic regularization via Sighorn optimal transformers. What does this mean in practice? It means the model understands the meaning of words, not just their frequency. We used fast text word embeddings with 300 dimensions. The model was configured with 6 latent topics, 200 encoder units, and was trained for 500 epochs. On the right of the slide, you can see our data pipeline. We start with 847 initial records from IEEE Explore, Scopus, and Web of Science. After filtering by venue quality, citation count, and relevance to explainability, we retain 156 papers. These were processed through fast text embeddings and then through the ECRTM model. which discovered 6 latent topics. Here are our first results. The ECRTM model successfully identified 6 core research domains. The topic 1, segmentation architectures, including UNet transformers and hybrid models. The topic 2 covers explainability methods like GradChem, SHAP, saliency maps, and attention visualization. The topic 3 addressed the evaluation protocols, going beyond the dice coefficient to include Hausdorff, distance, and clinical validation. Topic 4 examines clinical integration, specifically radiologist trust, workflow integration, and FDA approval. Topic 5 relates to datasets characteristics, particularly the broad challenge, multimodal MRI, and class imbalance. And topic 6 captures the emerging techniques, such as uncertainty quantification, federated learning, and self-supervised learning. What is significant here is that the ECRTM model discovered the semantic connection automatically through semantic analysis rather than manual categorization. Now, the most important findings. First, regarding architectural alignment, as can you see in the chart on the left, transformer-based architectures show a 67% correlation with attention based on explainability methods. Traditional CNNs show only 41%. This is a significant difference. Transformers are naturally more aligned with interpretability because of their built-in attention mechanism. Second, look at the performance table on the right. The best model achieved DICE score 0.92 for whole tumor segmentation on BRAD's benchmarks. However, and this is crucial, when the same models are deployed in real hospital, performance drops by 5 to 10 percentage points. This gap is caused by data heterogeneity, different acquisition protocols, scanner variations, and unusual patient presentations. Third, at the bottom right, we compare post hoc versus in-stream explainability methods. Post hoc methods like GradCam are easier to implement and require no retraining, but they may not faithfully represent the model actual decision process. In-stream methods based on attention mechanism are faithful by design, but may reduce overall accuracy. Most practical systems will need a combination of both. Conclusion, methodology. Well, now let me share our conclusions, starting with the methodology. First, in case discovery or ECRTM approach proves that neural embeddings can uncover thematic relationships that traditional keyword-based on search completely miss. Second, scalability. This methodology can efficiently synthesize thousands of papers, transforming unstructured text into navigable knowledge maps. And third, precision and reproducibility. The use of thick-horn regularization ensures high topic coherence, making the entire review process robust and reproducible. As you can see at the bottom of the slide, we compare the traditional search approach, which is manual and linear, with our ECRTM approach, which is automated, neural, and scalable. Now, the thematic conclusion and future outlook. On the left, our 3 key findings. First, XAI is mandatory transparency is no longer an optional feature. It is now a regulatory and ethical requirement for patient care. Second, clinical validation is urgently needed. We need rigorous trials that verify whether XAI actually improve doctors' decision making. And third, the performance gap between benchmark and clinical reality is significant and must be addressed. On the right, we propose four future directions: uncertainty quantification, multimodal attention, clinical validation through rigorous trials, and interdisciplinary teams bringing together computer scientists, radiologists, oncologists, and regulators. To conclude, deep learning has transformed brain tumor segmentation, but explainability remains the missing piece for clinical adoption. Our ECRTM methodology offers a new paradigm for systematic literature review, and our findings highlight the urgent need for transparency, clinical validation, and interdisciplinary collaboration. So, well, thank you very much for your attention. I'm happy to answer any questions.
Thank
Okay.
you.
And do you have any
Yes,
questions
ma'am.
for him?
Ah, Thank
Yes,
you
ma'am.
for your wonderful
Please.
presentation. It was informative and engaging. I truly appreciate your effort. I have two questions. What is the main technical contribution of your work?
Okay, the main technical contribution of my work. Hmm. Okay, the main technical contribution of, well, our work is the ECRTM paradigm for systematic literature review. Unlike traditional keyword-based search, our approach combines variational autoencoders with semantic regularization via synchron, optimal transport, which ensures that discovered topics are semantically current, not just statically grouped. This allowed us to automatically discover six core research themes from 156 papers and identify a key finding that transformer architectures show a significant stronger alignment with explainability methods, with a correlation of 0.67 compared to only 0.41 for traditional CNNs. This reveals a natural connection between architectural design choice and the potential for clinical interpretability.
Okay. What are the key performance improvements achieved in your research work?
Uh, Sorry, can you repeat the question?
What are all the key performance improvements achieved in your research work? What are the key performance achieved in your research work?
Okay. Well, our work is a systematic review, so rather than proposing a new segmentation model, our key contribution is analyzing performance across the literature. From our review of 156 papers, the best performing architectures are transformer hybrids, achieving DICE scores of 0.92 for whole tumor, 0.86 for tumor core, and 0.82 for enhancing tumor on RAD-TS benchmarks. However, a critical finding of our analysis is that these benchmarks results do not fully translate to clinical practice. We document a 5 to 10 percentage point drop when models are deployed in real hospital settings. This gap highlights exactly why explainability is essential. Clinician needs to understand the model decision, especially when performance may be lower than expected.
Good. Thank you.
Thank you too.
Okay. Miguel, one question for you. How reliable is your neural embedding based thematic discovery? Means, could different embedding model produce different topic interpretations?
Okay.
Could different embedding models produce different topic interpretations?
Uh, yeah, that's an excellent observation. Different embeddings models could indeed produce different topic groupings. In our study, we use fast text embeddings with 300 dimensions because they capture subword information, which is particularly useful for the technical and medical vocabulary. If we used, for example, VERT-based embeddings, The topics might shift slightly due to difference in how contextual versus static representation encode meaning. However, the ECRTM model mitigates this sensitivity through synchron regularization component, which enforce semantic coherence regardless of the specific embedding space. In our experiments, the 6 discovered topics align well with expert knowledge of the field, which give us confidence that the results are robust. That said, evaluating the impact of alternative embeddings is certainly a direction for our future work.
Okay, fine, good. Now we can start with the new session. Next paper.
Okay.
Thank you so much, Miguel, for that wonderful presentation. Now that our other session chair is here, I would like to reintroduce her, Dr. Poonam Relkar. She is an associate professor in the Department of Computer Engineering at Sihagar Technical Education Society in Srimati Kashibai Navle College of Engineering, Pune, India. She has published over 30 papers in the national and international journals and conferences and has authored a book. Her research interests include the Internet of Things, machine learning, security, and database management system applications. Ma'am, would you like to give some opening remarks? Ma'am, you're muted.
Then we will continue. At the end, I will give the concluding remarks.
Okay. Thank you so much, ma'am. Next, I would like to proceed with our next presenter, Gurdal Ertek. He would present his paper on Autodone, an interactive tool for the automated testing of group means in post-hoc visual analytics. You may share your paper by presenting your screen. I would also like to apologize to everybody in advance if I mispronounce your name.
Yes. Can everybody see my screen?
Yes, sir, we can see your screen.
All right. Let's get started. All right. First of all, before I start, I want to say that the slides that I will be presenting right now, they are available here under this link. So if you want to scan from your telephone, it's available as a flip book, which you can browse through from there. Okay. So the title of this presentation is Autodone. And Autodone is actually a tool. It's a software. It's an online software. And what does Autodone do? It does automated testing of group means. And after that, it does post hoc visual analytics. So first, it calculates the group means and then compares them. It does formal statistical testing. And then after that, it visualizes the results of the statistical testing. Okay, so this is what the software does. And this tool right here, actually is solving a problem that I personally have been facing for more than 30 years. For 30 years, let's say we have two variables, okay, one categorical factor, one numerical response, and I want to see, the differences. If the differences between the different categorical values are statistically significant. For example, delays at an airport, are they same across the airports, or is it, the mean is higher on one airport? And there's no automated tool to do this. So then I said, okay, now that we can do vibe coding, why don't I write this software myself? So together with the help of my colleagues, we worked on the methodology and also prepared some sample data sets. And I did the coding part and would be very happy to tell you today what we have done. So it's a tool for automated statistical hypothesis testing. This is me. You can tell from the, I'm same as the photo, right? And these are my colleagues, Dr. Gül Tokdemir from Çankaya University in Turkey, Dr. Supan Arisyan from Australia, and Dr. Mohammed Hammoudi, again from United Arab Emirates, but different university. Okay, so these are the co-authors of this paper. So this comparison of means is something that every single domain has. In healthcare, especially in medical research, there's statistical hypothesis testing, comparison of means. In engineering, but there is no proper tool until now to do this. And we are basically assuming a non-parametric analysis because in real life, I have a lot of experience with statistics and probability and statistics. In real life, I mean, parametric assumptions are almost never satisfied. If it's satisfied, probably it's not going to be satisfied for the next group or the next subsample. Okay, so even if it's satisfied over the whole sample, it's not necessarily satisfied over the subgroups or subsamples. So it's just immediately better to do a non-parametric tool. And the post hoc analysis can be done through different methodologies, which I will be telling you about. And we did the coding with vibe coding with ChatGPT 5.2. And basically, ChatGPT is a large language model. And again, I'm really proud of this work because, again, I have been trying to find such a tool myself for the last 30 plus years, but there is no such tool. And now researchers across the whole world and even practitioners can use this tool to do formal statistical analysis together with posterior visualizations to come up with practical insights. So the objective is to introduce AutoDone, a user-friendly automated tool for hypothesis testing without requiring coding. So no coding is needed. You'll see the tool as well. And until now, there has been no automated tool in the world to do this. Existing platforms are either commercial, but then the ones that are not commercial, they require programming. And again, there is no automated tool. And this tool can significantly reduce the time and effort for analysts for providing nice results and because of the visual analytics provided. And again, this is applicable in every domain. Okay, and the tests that we do, the statistical tests that we conduct are first Kruskal-Wallis test, and then after that we call it post hoc. We do Dunn pairwise test, which gives the tool its name. As you remember, the name of the software is AutoDunn, and Dunn is coming from the Dunn test. So basically, if you have, let's say, groups within your sample, let's say different airports, are the means across these airports, let's say delays, flight delays across these airports, are they the same or are they different? First, you could do the Kruskal-Wallis test to see if all of them are equal or not, and most likely this test will result in the result, okay, at least one of them are statistically significantly higher than the other. So they are not all same, but then you have to do the pairwise test. You need to compare airport 1 to airport 2, airport 1 to airport 3, etc., etc. So that one is the Dunn pairwise test. And since when you are doing pairwise tests, you need to do some error control, especially this Bonferroni correction is very important so that the errors do not, the tolerance that you give, which is represented by alpha, which we call as threshold, okay, and if the p-value as a result of the test is less than alpha, the hypothesis is rejected, otherwise it's not rejected. So this Bonferroni correction is needed a lot. And I did the coding with ChatGPT 5.2, and it's deployed under Streamlit. Actually, it's an online software that you can use even now. So this is the software, the Kruskal-Wallis Dunn end-to-end analysis through AutoDunn software. Okay, and it's developed by me. And the results that you obtain for the graph, you can view them here. So the first thing you do is you drop your file. In this case, we dropped a data set on airports. Here, the airport itself is the categorical factor, and the delay time is the numerical response. And then we get the statistical test results. Okay, so here you can see airport 3 has a mean of 22 minutes delay, and airport 8 has a mean delay of 19. Obviously, of course, this is more than that, right? But is the difference statistically significant? And the answer lies in the adjusted p-value, and the p-value is like almost zero. Yes, so there is a very, 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 very strong support for claiming, okay, on airport 3, the flights have more delay than airport A. How? Well, because the p-value is too small. And What are the mean values? These are the mean values. Okay, and then of course this table goes on like this. It shows the list according to decreasing p-values, but even these ones are really small. So typically the threshold p-value we take is typically 0.05. Okay, and of course when you do Bonferroni, for each test it will be less, but still these are very high. Okay, so now we can also visualize the p-values as a heat map. Okay, and you can see again each cell in the heat map shows the p-value, and of course smaller p-values mean statistically significant differences. Statistically significant differences in the means. Okay, then we do other visualizations through directed significance network, which can be exported into a dot file, which can be visualized with an online tool. So this is the visualization within the software. So you can see here the stochastic dominance relationships as a network. So if there's an arc from a node to another node, that means there's a statistically significant difference in the means. Okay, and you can export the source of this network definition to a dot file, and the dot file looks like this. So basically the dot file is a graph that describes the links on the graph along with their labels. Okay, and now you can use another software. I think it's a wonderful software for visualizing such dot files. As you can see, the resulting graph layout algorithm is much more clean, much more better. So from here you can directly see airport 02 is stochastically dominating pretty much everything except airport 13, and airport 10 is stochastically dominated by pretty much all other airports. So what does this mean? Very clearly, airport 10 has the least flight delays with very strong, very high statistical significance. Statistical significance. That's what it means. Okay, and here if you go here, on the other hand, airport 02 has the highest flight value for the most flight delays on the average, okay, with very high statistical significance. So already, if you have a data set from your real world application, you can already analyze it using this tool. And then there's another method called arc diagram. Actually, this method we had developed with one of the co-authors and with the two of the co-authors. So this arc diagram shows the same graph as an arc diagram. Arc diagram is a special type of visualization. So again, you can see that airport 1 is dominating airport 12, it's dominating airport 11, etc., etc. You can see those things as well. And there's one more visualization, diffogram. Here, the green lines, they show the statistically significant differences. Personally, this is not my favorite visualization, to be honest, but it was developed, I think, by IBM. Or SPSS, and it's quite popular. So, I mean, it's mentioned a lot in the literature, so I put that as well. And the source code is also available. Actually, we even created a software. We have even the website, otodun.com. If you go to otodun.com, you can see the documentation of this software, including the motivation, the research itself, what we did in the research, the software, and the link to the software. So you can also start immediately using the software. The software is running already under Streamlit. If it's not used frequently, you have to wake it up. And it's, there. The software is now waking up, and then you can use it. All right. So there are some limitations which you can look into later. I don't want to exceed my time. And there could, of course, be some new type of analysis. There could be some new methodologies of visualization. And there could be dynamic coloring. Okay. Let's say you could just have some interactivity in the tool. Like if you decrease the p-value, maybe the graph could be reconstructed, etc. But as summary, Autodun provides a universal automated tool for mean comparison, bridging the gap between complex R Python libraries and non-technical users. So now everybody can test their statistical hypothesis automatically with a very simple tool, easy to use tool, but could generate very rich results. And this is the first automated tool of its kind in the world, to the best of my knowledge. So if you are interested, you can scan any of these. I think the one that I would scan the first would be slides as flipbook, because in the slides you have these other links as well, or you could take screenshot if you like. So the source code of the software is available under GitHub. I'll just do like this. The source code is available under GitHub. You could run the application itself. If you want to take a look at the datasets, you could download the datasets, the website, and finally the software that I showed you for viewing these graph files. It's also over there. So that's the end of our presentation. Just a few words about me, in case you'd like to communicate with me in the future. This is me. I work at UAE University in Al Ain, which is a city in United Arab Emirates. Maybe you know Dubai, Abu Dhabi. So Al Ain is a smaller city here. I work here. I have more than 35 years of experience in the field. And one of the things that I'm really proud of is actually I also do a lot of blockchain work as well. That one is not research, but it's mostly this blockchain work is mostly hackathon and joining hackathons. So that's me. I'm overall a IT person teaching in a business school. Thank you so much for your participation. Yeah, that's
Okay.
it.
Good.
Yeah,
My
this is the tool. You can use, anybody can use the tool if you want. Okay, this is the tool. Yeah.
good. Sir, is this software scalable for large data set? And does it support exporting the results for the academic publication?
Yes, very good question. Well, when you say large data, not for maybe 10,000 rows, but a few thousand rows, yes. But I don't know. I didn't try actually. I didn't try scalability. I think we tried with I don't know, this data set here. 1 minute, let me check. We tried with this data set. It's working, which is the airports data set. This is a
How
real world
much
data set.
records are there?
What's that?
How much records are there?
It's 8,000. So for 8,000, very easily scalable. Very
Okay.
easily. I mean, up to 10,000 easily scalable. My guess it would be scalable up to, maybe 30, 40, 50,000, maybe even 100,000, but no more than that. But for sure, until 10,000, it's scalable. Now, the second part of your question is, I'm so glad. Actually, this is another reason why I believe this is a very important research. As you can see, software is available as source code. So this is the source code of the software, the Python file. Okay. And it's using just the normal libraries, right? And the results, I checked, the results make sense. I didn't compare to SPSS results, to be honest, but I mean they make sense. So the answer to your question is yes. I mean, you should be able to use this tool and get the results, and you see the results on the screen, and then you can just download these results and then put them into your paper, and then you could cite the research, and hopefully this paper will get a lot of citations, because I think it's worth it, because it solves a real headache. It really solves a big headache that I had for 30 years. I have good data sets. Why should I have to write Python code, or why should I have to go to SPSS, do every single pairwise test one by one? It doesn't make sense. So this is much, much better.
Okay, good. Ma'am, if you have question, Lakshmi ma'am, you can ask.
Yes, ma'am. I have only one. How does automation reduce human error in hypothesis testing, sir?
Come again?
I will send you the chat. Just check in the
Sure.
chat.
Sure. I'll read from the chat then. How does automation reduce human error in hypothesis testing? Of course, it also reduces human error in hypothesis testing, for sure. Because, when we do this as humans, we have to, make selections, and these software, they have so many settings. I mean, this one is doing all those things automation. For example, when we are doing this pairwise test, are we sure we are going to obtain the correct adjusted alpha value for each pair, which will due to Bonferroni? So it will reduce human error as well.
Okay, thank you.
Thank you. Thank you, Dr. Lakshmi. Any other questions? Please feel free to share this presentation and software with your colleagues, because I mean, I'm sure you have colleagues who have data set. And again, as long as you have a data set which has one categorical factor and one numerical response, okay, you just use this. For example, the first one could be the algorithm, and the other one could be, for example, the results of the algorithm, let's say performance results. So you have one numerical categorical factor, one numerical response. Again, it's so universally applicable software. It's a very, very simple but extremely effective software.
Yes, sure, sir.
Thank you so much for that presentation. Now, I would like to call upon you again to present your next paper on electrical vehicle acceptance in Europe across countries, gender, and education, a statistical algorithm.
So it's my turn again, right?
Yes, yes.
Okay, I will present my next paper then. Okay. All right. So you can tell from this presentation also, I like statistics a lot. So here we kind of formalized, actually we just formalized the statistical algorithm that should be applied. We just wrote it as an algorithm very clearly, and we applied it for the following case.
So sorry to interrupt, sir. We can't see your screen.
Sorry.
Yeah.
You can not see my screen. Let me share again. Sorry.
Yeah.
All right, so welcome to my second presentation. 1 minute, let me just minimize these things. Okay, all right, so you can see, okay, again, for this presentation also, please feel free just to scan this barcode so that you can just open up a link, and in the link, you can browse through the PDF of this presentation. So again, I love statistics, and this time we didn't write a software. Actually, this was an earlier research that we did. And in this research, I got so frustrated because, we have to do all these tests one by one. So I said, let's write a software on it. And together with the help of my colleagues, we wrote the other software, which is Autodun. But whatever I showed you with Autodun, actually here we did manually, unfortunately. And we applied it for analyzing electric vehicle acceptance in Europe across. And then we look at the different countries, we look at the genders, we look at education level. So how is electric vehicle acceptance affected by the countries, by gender and education? And we use this statistical algorithm. So by the way, there's an algorithm for countries, there's another algorithm for genders, there's another algorithm for education level. So this is the algorithm for testing hypothesis across countries. So actually for factor, I didn't use the word factor, I used the word determinant, because the factors of this analysis were the responses of the previous work that we did. Okay, so the determinant or the factor, and then we look at each country, and if the factor is binary, then we create a contingency table, we perform chi-square test, and then if if they are independent, then if they are independent, then we test for equal means. If they are not independent, then we perform chi-square test of independence for all pairs, then draw statistical dominance graph. If the determinant is numerical, then we other steps. But again, eventually what we obtain are those dominance graph that you have seen. Okay, so again, this study was conducted in Europe, not the whole of Europe, but in 4 countries, Denmark, Norway, Germany, and Hungary. And it's related to electric vehicle acceptance and the factors that influence that electric vehicle adoption acceptance. Okay, so EVs are very popular nowadays. They are being more accepted. I did my first work on electric vehicles many years back, more than 15 years ago, where we analyzed, we had a client company, electric vehicle charging station company, and we came up with an optimal solution of where they should locate their electric vehicle charging stations in Istanbul. And we used, of course, their real-world data set, and we also use real-world map data of Istanbul. Now, years later, electric vehicles are being accepted more and more. Right now, I'm living in the UAE. Everywhere we see these Tesla cars, BYD cars, many different Chinese brands. Most of them are actually electric vehicles. So now it's increasing in adoption. Okay, so it's a valuable case to analyze. Is it sustainable or not? That's a different story, by the way. Everybody assumes that electric vehicles are sustainable. I would like to put a, just remark there. It's not always the case, but still, if you want electricity and if you have a sustainable way of generating electricity, then electric vehicles could be sustainable. Okay, but today's discussion is not about all the positive and negatives about EVs, but the specific factors that you choose, and we use specifically chi-square and non-parametric testing of means through again chi-square and Dunn test. And we look at the effects of country, gender, and education, and we do the pairwise comparison and share our results. Okay, we're just saying the same things here. Okay, so where does the data come from? The data itself is actually available under Mendeley data, and it was reported in a paper in Data in Brief. So Data in Brief is what I would call a data journal. So what is a data journal? This is a new generation of journals where the paper itself is describing a reliable, verified, valid data set. So it's a very interesting because this gives me an unlimited opportunity to write papers. If there's an interesting data set in this Data in Brief journal, I can get that data set. It should be, of course, a recent data set. And if I analyze that data set, I have fresh results for the domain. Or if I develop an analytics methodology to analyze that type of data set, that's another type of analytics research. So I would say this is one of my top career advices. Anybody doing work with data, especially if you are a bit versatile, or anyhow, I mean, if you are into analytics, data analytics, don't go searching for data sets from Kaggle. Do not use Kaggle data sets in your research. Why? Because Kaggle data sets, they are not verified, they are not peer reviewed. And when you try to publish your paper, it will create a big problem. Instead, choose data from Data in Brief journal. So that's the first journal. Then there's another journal called Data. The name of data journal is Data, and it's by MDPI. And there's another journal called Scientific Data. So these three journals, this last one is by Springer Nature Group. Okay. So these three journals are amazing. Okay. So these are the 4 countries. The education level is low, middle, high, and gender, of course, male, female. Okay. So this is again the source data set, original source data set. And this is where the data set resides under Mendeley data. You can go there as well. But actually, we took that data set earlier, and we have 2 earlier research studies. Again, as you can see my name here. And actually, one of these studies was also together with one of our co-authors in this study as well. So we have 2 studies. We first compared the performance of classification algorithms. Then we compared the performance of classification algorithms across these attributes. But then I realized, wait, we need to also do statistical testing, proper statistical testing. So that's what we are doing here. And the methodology that we are using is the same methodology underlying the statistical stochastic dominance that I showed in the previous presentation. So the 3 of us, myself, Dr. Gültok Demir, and Dr. Muhammed Hammoudi, we had developed this earlier research where we formalized graph-based visualization of stochastic dominance in statistical comparisons. So we are now going to apply that here. So here we have some categorical factors, which we refer to as determinants, and we have also some numerical factors. These are both, all of them are responses. These are responses, but they were factors in the previous studies. In the previous studies, these were the factors that were used in classification. Now they became responses. So these are the question IDs and what the question talks about. Society must reward electric cars instead of petrol or diesel cars. This is the answer to question 14. Suiting daily driving needs is a reason that I would choose electric vehicles. Opinion changed regarding electric vehicles during the past year. Is purchase price important for you? That's another factor, etc., etc. Okay, effect on global climate, less noise, and positive effect on the local environment. So these are the tests that we use. This is the algorithm. And we use this online tool. By the way, if you don't want to use AutoDoom software or you want to do other things, this is a wonderful online source that you could just use. You can just put your data set and conduct, I think, 30 different statistical tests. They are available all for free, and it's like a very nice substitute, online substitute for SPSS or other software. And this is also very, very nice that you could immediately show to your students in your lectures. Okay, so now let's look at the results. All right, so regarding purchase price, being influential in electric vehicle adoption. Is it the same across countries? Well, in Hungary, purchasing price is a much more of an important factor compared to others, even in Germany and Denmark. So for these three countries, they are dominating Norway. So in Norway, price is not an important factor, but the others, they are more important. For in the other countries, it's more important. Okay. What about the effect on global climate? People in Hungary are very sensitive. They are more sensitive than all these other countries. So Hungary is dominating. We could say that Hungary is the most sensitive country, of course, assuming that the sample is reflecting the population, etc., etc., assuming that the data collection was unbiased, etc., assuming all the right things. The country that has the most sensitivity with respect to the effects of global climate is Hungary. Also, when it comes to noise, same. Also, when it comes to environment, Hungary. So, if we want to increase the adoption of electric vehicles in Hungary, what are we going to emphasize? Are we going to emphasize price? Maybe also that one you can emphasize, but especially we could emphasize impact on the environment and humans. This is a very fundamental result, right? And when it comes to incentives, people in Norway want incentives over petroleum and diesel cars. Which country wants this? Norway wants that. What about suiting the driving needs and opinion change? Germany. Okay, you can see these dominance relationships. Okay, and these are the results summarized. What about education level? Here are the results. So for high education people, these are the important things. For high and middle education people, this purchase price is important. And for low education people, these are the things that are important, right? For low education, low education is dominating here, and here, and these are the two questions that are important for that. Okay, and gender-wise, actually turns out there's no difference except for female. The opinion towards electric vehicles has changed more positively in the last year. So they dominate the mean value is higher than for the males. So there's a stochastic dominance. But for the other factors, they are the same. This is very interesting. Of course, you can say, well, let's take a look at like a confounding analysis, like gender country or gender education level. Maybe that will be the next paper. Okay, so we analyze these effects of country, education level, and gender. We use the different statistical tests and we visualize the results. And these could be used for marketing and policy alignment as well. And of course, there are
Sorry
some
to interrupt,
limitations.
sir, but your
What's that?
time is up. I would
All
request
right, that's
you
that's
to
enough, and no need to talk about myself again. Thank you so much. My time is up. My presentation is also finished. Thank you so much.
the session
Okay.
chair if you would like to ask him any question.
Yes. Sir, can your statistical algorithm be adapted for other sustainability topics like renewable energy or public transport acceptance?
Okay, to be honest, it's a very general algorithm that is customized or that is expressed in terms of this specific methodology. Of course, it could be applied to any domain, especially in renewable energy domain, for sure.
Okay, fine. Lakshmi ma'am, you can ask.
Super, sir. Actually, wonderful presentation
Thank you.
you have given. Only one question I have. Does environmental awareness differ by gender in any usage?
Could you type it again, Doctor? I have kind of voice issues in my computer. Could you please type? Sorry, huh? Waiting for your question in the chat. Does environmental awareness differ by gender in electric vehicle usage? Okay, first of all, this is not about usage, but this is about adoption intention. So this data set, source data set, is about adoption intention. Environmental awareness differ by gender. Let's take a look at the results. So wait. Uh, Let's go to the results for gender. Again, the beautiful thing about our methodology is we don't need to interpret any tables. We just look at these simple graphs. Okay, environmental awareness across genders, there is no arc. So no, these are not influential at all. Across genders, there's no statistical significance. I mean, there may be, of course, a little bit difference, but the differences are not statistically significant. The only thing that is different, statistically significant difference is in the change in opinion, that in that one, female is more than male. But for the others, no, they are the same. So male and female in these four countries, they have the same, approximately the same level of sensitivity when it comes to impacts of environmental impact when it comes to adoption of electric vehicles. But again, as we shared earlier, there is an effect when it comes to education level, and especially country-wise, there is an important distinction, but not when it comes to gender. As you can see, there are no dominance arcs.
Thank you, sir.
Yeah, these are the questions that you are asking about, the environmental impact questions. There are no arcs, so there's no statistical dominance there. All right. Thank you so much.
Thank you so much, sir. We appreciate your time and effort in delivering such excellent presentations.
Thank you. Thank you. I love this conference, and I thank all the session chair and all the participants and all the people who are contributing to this conference. This is one of the best organized conferences. That's why I spent too much time preparing high quality slides. And I worked until 3 a.m. for the quality. So I'm glad to hear your positive words. Thank you so much.
Thank you so much, sir. Really appreciate your work. Yes. Now, moving on. Next, I would like to call upon our next participant, again, Miguel Bone, to present his paper on feature engineering in collaborating filtering, a brief survey on modern recommendation approaches. So you may present your paper by sharing your screen.
Okay, yeah, now I'm going to share my screen. Okay, well, good morning, everyone, again. Thank you for the opportunity to present our work at the ICICT 2026. My name is, well, Dr. Miguel Bon. Can you wait just for a second? Okay. Yeah. Now, well, I'm here on behalf of my co-authors, Remilio Hurtado, Roberto Romero, and Rodolfo Bojorque from Universidad Politécnica Salesiana in Cuenca, Ecuador. Our paper is titled Feature Engineering in Collaborative Filtering, a brief survey on modern recommendation approach. So in the next minutes, I will show you how we applied a neural topic model to systematically review 128 papers, and why integrated gradients is the most principal method for explaining deep recommender systems. Here is the structure of my presentation. Okay, I'm having some troubles with my slides. I don't know why. Okay. Okay, yeah. So here is the structure for my presentation. I will cover the introduction, the problem statement. Okay, problem statement, related work, methodology, three sets of results, evaluation frameworks, and conclusions with future directions. Now, let me start with some context. Recommender systems have evolved from simple heuristic to deep learning models that handle millions of interactions in real time. This evolution raises a fundamental question. How can we construct features that maximize prediction accuracy while also producing explanation that users can trust? And here is the paradox. Deep learning achieves unprecedented accuracy, but through a complex, non-linear transformations that resist straightforward interpretation. This is the central tension of our work addresses. So, what's exactly the problem? First, black box features. Deep collaborative filtering learns that layered representation that are impossible to interpret directly. Users cannot understand why items are recommended to them. Second, unreliable explanation methods. Attention weights do not necessarily reflect causal importance. Vanilla gradients produce noisy attributions that violate basic axioms. And third, the need for axiomatic attributions. We need methods with mathematical guarantees, sensitivity, and implementation invariance. Only integrated gradients satisfies both. Before presenting our objectives, let me position our work within the existing literature. On the left side, you can see the prior survey gaps. Bobadilla et al. Provide a foundational survey but predates deep learning. All Unit et al. Offer comprehensive neural coverage but with a limited attention to explanation methods. Banat et al. Cover latent factor models, but without examining gradient-based explanation. And Ferrari et al. Highlight evaluation challenge, but only briefly mention attention-based explanations. On the right side, our 6 original contributions. First, a novel ECRTM-based pipeline for reproducible literature synthesis. Second, 6 thematic clusters with semantic relationships. Third, comprehensive integrated gradients treatment for collaborative filtering. Fourth, critical evaluation of baseline selection strategies. Fifth, semantic visualization via interactive graph. And 6, gap identification in gradient-based explanation research. Given these gaps, our research has 4 main objects. Objective 1, apply the ECRTM model to 128 peer-reviewed articles for automated reproducible thematic analysis. Objective 2, provide a comprehensive treatment of integrated gradients with axiomatic foundations. Objective 3, evaluate baseline selection strategies and provide practical configuration guidance. Objective 4, identify open challenge and future direction in gradient-based explainability for recommender systems. Now, let me explain how we conduct this review. This is one of our main contributions. We employed the inviting coherence regularized topic model, or ECRTM. This model combines variational autoencoders with semantic coherence via Sighorn optimal transport. In simple terms, the model understands the meaning of words, not just their frequency. Our search strategy used the Boolean query, collaborative filtering, and recommender system, A&D feature engineering, A&D X AI, yielding 128 articles from IEEE, ACM, Scopus, and Web of Science. In the middle, you can see our training objective. Equation 2, it combines three components: reconstruction loss to reproduce the original documents, KL divergence to promote topic diversity, and the concurrence regularization to align topics with semantically current word vectors. This is what makes ACRTM fundamentally different from LDA. On the right, our data pipeline shows the sixth phase from article to survey synthesis. Here are our first results. The ECRTM model identified 6 core thematic clusters. T1, fundamental architectures, core recommender and collaborative filtering frameworks. T2, evaluation frameworks, metrics, performance, and ranking. T3, feature embeddings, the central topics, covering latent factors and deep learning vectors. T4, similarity computation, using correlation, neighborhood methods. T5, adaptive personalization, context-aware and temporal methods. And finally, the T6, gradient-based explainability, attribution gradient sensitivity analysis. Okay, now let me show you the thematic relationship network generated by ACRTM. On the right side, you can see the semantic graph, where nodes represent topics and edge reflects similarity based on cosine similarity and point-wise mutual information. The most important findings here is the structural role of T3, which occupies the central position connecting all their other topics. This confirms that embeddings are the methodological foundation of the entire field. Notably, the strong connection between T6 and T3 confirms that the gradient attribution methods are particularly relevant for explaining and embedding based on natural model. This is highlighted in the gold in diagram. And well, the bridge between T5 and T1, adaptive personalization links back to fundamental architectures, reflecting how context-aware methods extend core CF paradigms. Okay, now the most important part of our work, the results. On the left, you can see the integrated gradients formula, equation 3. For neural collaborative filtering model F, given an input x and baseline x prime, integrated gradients computes the attribution for each feature as a path integral from baseline to input. Notice that the gradient is evaluated at the interpolated point x prime plus alpha times the difference. This is not just a heuristic, it has mathematical guarantees. Below that, the equation 4 shows the practical Riemann approximation. Using my steps where m range from 50 to 300. The three axiomatic guarantees are sensitivity. Any influential feature gets a non-zero attribution. Implementation invariance. Equivalent models produce the same attributions and completeness. All attributions sums exactly to the prediction difference. Now on the right, the comparison table is key. Attention weeks fail both actions. Vanilla gradients fail sensitivity. Deep lift fails invariance. Only integrated gradient satisfies both. This is why we call it the gold standard. Below that, the configuration table shows use 0 or average baseline 50 to 300 steps, targeting the user embedding to explain preference. An important aspect of our work is the dual evaluation framework. We evaluate we evaluate both recommendation quality and explanation fidelity. For recommendation quality, we use standard metrics RMLE, MAE, and AUC for accuracy, and precision at key and the NDCG for ranking relevance. For explanation quality, we propose two tests: deletion AUC, where you remove features in order of attribution importance and measure how quickly the prediction drops. The insertion AUC, where you add features by importance and measure how quickly the prediction recovers. This measure attribution faithfulness. However, there is an important key insight at the bottom of the slide. Faithfulness is not the same as human utility. A user receiving attribution over 128 dimensional embedding vectors may not understand what they mean. Translating this attribution into natural language remains an open challenge. Let me share now our conclusions. First, the ICRTM methodology uncovers 6 thematic clusters and latent correlations that manual reviews constantly miss. Second, feature embedings occupy the central position in the thematic network, confirming their role as the methodological foundation of the field. Third, gradient explainability connects strongly to feature embeddings, confirming gradient attribution is particularly relevant for neural models. Fourth, integrated gradients is the only method satisfying both sensitivity and implementation invariance. The completeness property ensures full prediction decomposition. And fifth, baseline selection matters. Zero baselines represent absence of information. Average embeddings represent typical user behavior. The choice is task dependent. On the left, we acknowledge 4 limitations. This is a survey without experimental benchmarking. Our corpus may not capture all publication results, depend on hyperparameter choices, and computational overhead limits real-time applicability. On the right, we propose 5 future directions: natural language explanations, where translating attributions into human readable text; context-aware IG, computing attributions over contextual features; GNN interpretation, applying the integrated gradients through graph neural network layers; real-time deployment, optimizing forward backward paces; and experimental validation, benchmarking on movie lens and Amazon datasets with user stats. To conclude, this review examined feature engineering in collaborative filtering with a central focus on integrated gradients. As the explanation technique, our ECRTM methodology revealed 6 thematic clusters, and our analysis demonstrates that integrated gradients provides the only axiomatic guarantees suitable for explaining deep recommender systems. Here you can find our main reference, and our contact information is at the bottom. Thank you very much for your attention. I'm happy to answer any question.
Okay, good session. Can you explain in simple term how sensitivity and the implementation invariance make integrated gradients more reliable? Explain it
Okay.
in short terms, simple terms.
Yeah. Okay, well, now I think that I'm going to explain in simple terms how sensitivity and the grain is more reliable. Sensitivity means that if a feature actually affects the prediction, it must receive a non-zero attribution. So we never miss important features. For example, if a user preference for science fiction influence a recommendation, integrated gradients guarantees that feature will appear in the explanation. Implementation invariance means that two networks producing identical outputs will always receive the same attribution, regardless of their internal architecture. Methods like deep leads can give different explanations for functionally equivalent models, which is problematic. Together, these two properties ensure that explanations are both complete. Nothing important is missed and consistent. They depend on what the model computes, not how it is implemented. This is what makes integrated gradients more reliable than alternative like attention, weights, or vanilla gradients, which fail one or both actions.
Good. Okay, good.
Yeah,
Lakshmi
good
ma'am.
presentation. I have one question. How can demographic features improve collaborative filtering?
Okay, well, that's a great question. So, demographic features improve collaborative filtering in three main ways. First, they help address the cold start problem when a new user has no interaction history. Demographic attributes like age, gender, or location allows the systems to infer initial preference based on similar user profiles. Second, they enrich the feature space. Traditional collaborative filtering relies solely on user item interactions, but adding demographic provides site information that helps the model learn more robust latent representation, particularly in sparse data scenarios where interaction matrices have many missing values. Third, they enable user segmentation. The model can learn that certain demographic groups share systematic preference patterns, which improves recommendation accuracy for underrepresented users who have few ratings. However, it is important to note that demographic features also raise privacy and fairness concerns. Models must be carefully designed to avoid reinforcing biases related to gender, age, or ethnicity in recommendations.
Okay, thank you.
Thank you so much, Miguel, for such a wonderful presentation. A quick notice to everybody present here that we are running out of time. So, the future presenters, I would like you all to present your paper according to that. Next, I'd like to call upon Ibrahim C. to present his paper on From Prediction to Confidence, a survey of AI-based ECG uncertainty quantification methods. You may present your paper by sharing your screen.
Good morning. My name is Ibrahim C. I'm PhD candidate from Senegal. Today I present our survey from prediction to confidence AI. AI based ECG uncertainty quantification method. Our main message is simple accuracy is not enough in medical AI. We also reliable confidence. Let me brief show the roadmap. Okay. I will cover motivation, uncertainty, definition, three method families, Bayesian, evidential, and hybrid, then dataset metrics, key literature results, and short conclusion with real-world impact. First, I write topics major. CG models often output a level plus a softmax, but this confidence can be wrong. Models may be overconfident, especially with noise or distribution shift in cardiology. Overconfident mistake can be harmful. So we need a model that know to say I'm not sure. Why ECG particularly challenging? ECG is hard because of strong patient variability, artifacts, and noise acquisition differences across device and rare events with class imbalance. This factor increases the risk that the model is confident for wrong reason. Now I define uncertainty. What do you mean by uncertainty? Uncertainty tells us how much we should trust prediction. In calibrated system, if the model say 90% confidence, it should be correct about 9% of time. So uncertainty is about trustworthiness, not only accuracy. A short example made it clear. If a model predicts 90% confidence for 20 ECGs, a calibrated model should be right around 18 times. If it is right only 12 times, it is overconfidence. Uncertainty helps to decide, accept easy case automatically, and send uncertainty case to a clinician. Next to complementary type uncertainty. Uncertainty, epistemic, two complementary type of uncertainty. Epistemic uncertainty is model ignorance, hide for rare or out of distribution signals, ODD, and it is rediscoverable with more data. Aleatoric uncertainty is data noise, artifacts, and measurement variability, often irreducible. Reliable ECG AI should consider both. Now let method starting with Bayesian approach. Bayesian neural networks spread weight as distribution, not fixed values. Prediction marginalize overweight. If prediction vary across sample, uncertainty is high. The benefit is strong epistemic uncertainty, but the cost is higher computation. Next, the sampling-free methods. Dirichlet and EDL model uncertainty at the output using evidence parameters alpha. The total evidence S act as confident. Low S means high uncertainty. They are efficient and good for wearable. Then hybrid models combine both ideas. Hybrids use Bayesian internal layers with a Dirichlet heat. The goal is capture epistemic uncertainty like Bayesian neural network and keep efficient output like EDL with beta calibration. Here is a quick comparison table. This table summarizes the trade-off. Bayesian neural network variants improve epistemic uncertainty, but cost more EDL. Is low cost hybrid aims to both with medium cost. So selection depends on latency and deployment constraints. Now evaluation start with dataset. We focus on common benchmark, MIT BE, ASH, PTB Diagnostic, PTB XL, and Fusionet /Science challenge. The key point is dataset variability and shift strongly affect calibration. So evaluation must consider realistic noise and device differences. Next is the main evaluation matrix. We use probabilistics metrics, NLL, ACE, Beer score, predictive entropy, and mutual information. The key idea, calibration metric like ECE are critical because they tell if confidence match reality. To interpret numbers, I add the reference range. As practical guideline, ECE below 0.02 is excellent and 0.05 is often good, but threshold depends on task and dataset. So we use them as a reference, no strict standard. Now the key literature takeaway. Literature shows deterministic CNNs can be accurate but poorly calibrated. Bayesian and ODL method typically reduce ACL and nil while keeping similar accuracy. Hybrid often provides strong trade-off with good calibration and robustness. They tend align with GAL, etc. Now I will briefly show the real-world impact in connected health. In practice, uncertainty is very useful for telemonitoring, and wearable SSA is enable confidence-aware alerting to reduce false alarm and alarm fatigue. It also supports uncertainty-based triage. Confidence case can be auto-validated while uncertainty cases are escalated to clinician. Finally, it helps with out-distribution data detection if we have a new device, new population, or unusual ECG morphology. However, there are still important challenges. There are several open challenges. Sampling and assembling requires inference time, which is difficult for real-time use. Calibration protocols are not yet standardized across the CG dataset clinical. Validation at a large scale is still limited, and regulation require audibility, traceability, and strong evidence of safety and robustness, specialized for medical device. Finally, let me highlight a few feature direction. Feature direction include hybrid binary neural network and ODL combined with transformer for long-range temporal modeling. We also see ACG foundation model with multimodal clinical context. Another trend is edge optimized uncertainty through the compression, quantization, and efficient inference. And finally, online calibration for dynamic monitoring and federated Bayesian learning for privacy preserving uncertainty. I will conclude work on final message. Uncertainty-aware SAG AI enables safer deployment, fewer false alarm, 3 years of uncertainty case, and better behavior under distribution shift. The conclusion is uncertainty calculation by a high accuracy and high truth. Thank you for your attention. I'm happy to take a question.
Okay, good session. My question is, among variational inferences, like Monte Carlo dropout and ensemble methods, which approach perform best in real clinical settings? Which one is the best in real clinical settings?
You can repeat slowly.
Okay. But you have done variational inferences, like among the variational inference, like Monte Carlo dropout, then ensemble methods, which approach performs best in real clinical settings.
Yeah. Here I use a variational inference here because I want to implement from one to n a real Bayesian neural network method. I don't use Monte Carlo dropout, who is an approximate of a Bayesian neural network method. I want to use implement Bayesian neural network with the approach variational inference. Yeah.
Okay. Why is predictive uncertainty especially important in your ECG diagnostics as compared to other AI tasks?
Repeat someone, please.
Okay, I'm asking you slowly. Why is predictive uncertainty especially important in ECG diagnosis as compared to other AI tasks?
Yeah, uncertainty is very important for
Why?
cardiology. Yeah. For example, I use uncertainty for 3 years. It's permit to select a patient with high uncertainty to redirect a clinician and low uncertainty to treat automatically. Yeah.
Okay.
The objective is to triage. To triage.
Fine.
Good presentation, sir. Actually, I have one question. Can AI replace doctors in ECG interpretation?
SAG.
Can AI replace doctors in ECG interpretation?
No. Yeah, I can't not replace doctor interpretation. It is a solution who help doctor for treatment in diagnostic of SAZ rapidly and plus sure.
Okay, thank you.
Thank you so much, Ibrahim, for such an engaging and interesting presentation.
Okay, thank you very much. I come from a country English. My friend, my English is not fluent. I'm excused for this. Okay, thank you.
No problem at all.
Next, I would like to call upon our next presenter, Coachi Anda Elena, to present her paper on inclusive communication through universal design, designing accessible informational flyers to promote awareness, resources, and support for people with disabilities. I would ask you to present your paper by sharing your screen.
Okay, thank you. Can you see my screen?
Yes, we can see your screen.
Good morning. My name is Anda. I would really like to thank you for the opportunity to present our work today at ICICT 2026. I'm a student at the University of Aveiro, Portugal, and today I will present our article titled Inclusive Communication for Universal Design, Designing Accessible Informational Flyers to Promote Awareness, Resources, and Support for People with Disabilities, developed at the Department of Communication and Art within the Digimedia Research Center. This study explores how communication design can reduce information barriers and promote inclusion through accessible informational materials. Access to information remains a major barrier for people with disabilities. Many communication materials are still not designed inclusively, which limits awareness about assistive technologies and available support services. Accessible communication is therefore essential to promote autonomy, participation, and social inclusion. It's important to note that information needs to be accessible, easy to understand, and easy to remember. However, traditional communication often excludes users with cognitive limitations, sensory impairments, or low literacy levels. This reveals the need for more inclusive approaches to informational design. The main goal of this study was to explore how universal design principles can guide the creation of accessible informational flyers in order to reduce informational barriers, promote awareness of disability resources, improve comprehension, and also support social inclusion. As stated in the previous slide, universal design is what our work is grounded in, and it's an approach that aims to create products and communication usable by the widest range of people from the beginning, avoiding the need for later adaptations and promoting equal participation. The key principles that universal design has are equitable use, flexibility, simple and intuitive information, and also perceptible communication. These principles are what guided both the structure and visual design decisions of the final flyer. We adopted a qualitative and user-centered methodology based on an iterative design and evaluation process. Two informational flyers were developed, one for a general community and one for PVD, or people with disabilities. During the process, we continuously receive user feedback in order to reach the final product. The methodological procedure were carried out in 6 sequential stages. First, a literature review and graphic and content survey to establish the theoretical and practical foundation of our work. Secondly, the writing of informative content and definition of layout. Thirdly, the design of the flyer. Fourthly, an initial assessment with people with disabilities in collaboration with an association supporting people with disabilities. Fifth, implementation of improvements and reassessment with the sample. And finally, the finalization of the flyer. During the design phase, we used several accessibility guidelines inspired by web content accessibility guidelines, and also applying a clear typography, large font sizes, high color contrast, logical visual hierarchy, and simple language. These are the decisions we took to improve readability and comprehension. We also included multimodal access, meaning that both flyers included QR codes linking to an accessible PDF version of the flyer and audio formats. This allowed users to access information through different sensory channels. This was the initial evaluation before we conducted the test, and we concluded that our initial flyers had complex terminology, long sentences, small typography, weak visual hierarchy, and lack of visual cues. These results not only show the importance of real user testing, but also show that when we want to create a product for a certain community, we need to work together with the community. And as such, we decided to improve our design, to simplify the vocabulary, to shorten the sentences, to increase the font sizes, to have a stronger visual hierarchy and add more icons and logos to improve readability and visual understanding. It was our objective to balance aesthetic quality with accessibility. Our results significantly improved. We have, using universal design, we improved accessibility, readability, information comprehension, and also user engagement. The participants we tested our flyers with, 6 of them, reported easier navigation, a better understanding, and also a positive reading experience. Accessible flyers do not only function as informational tools, but also a mechanism of inclusion. And I think that our summit demonstrated that if we have effective inclusive communication, we need to have a clear visual structure, a simple language, multimodal communication, so that we can have both a QR code and a readable PDF file, and also active user participation. These findings confirm that accessibility is an iterative process. Guidelines alone are not sufficient. Direct involvement of people with disabilities is essential to reach a final product. Participants also express preference for multimodal formats and a particular preference for a video format or video content of our flyers. Although our study presented various compelling results, We also had some limitation, which is a relatively small participant sample, and also a focus mainly on visual and cognitive accessibility. Our future directions should include larger and more diverse participant groups, development of accessible video materials, and also an expansion to additional communication formats. Thank you very much for your attention. I will be really happy to answer any questions you may have.
Okay, good presentation. Anna, how did you ensure that the simplified language did not remove the important information?
Excuse me, let me just turn my screen share. That is a very good question. So, first of all, this was definitely a challenge, mostly because we wanted to convey all of the information, but we didn't want to take anything important out of it. So what we did was, firstly, we started to cut down on the text, what is essentially not needed for what we wanted to convey. There were some words, for example, that could purely be replaced by synonyms or could be tried to be explained with more words that are simple. There were also times when we decided that, because initially we had a lot of text, and we decided that, for example, when we listed all the organizations, what we could do to simplify it is just have an icon of the organization, the name of the organization, and maybe a very simple short text next to it. And with these strategies is how we managed to reduce really complicated words, really long descriptions to something short and concise.
Okay. Lakshmi ma'am, you can ask.
Good presentation. How does inclusive communication support diversity and equity?
I think that inclusive communication supports diversity in the sense of that it offers tools to a wide range of communities that do not have them. I think that inclusive communication would also include online communication, so for example, accessible websites, but it can also include physical media. And I feel like in the physical media area is where it's truly lacking, mostly because, well, physical media is also harder to develop. It's more constrained. But also when we think about physical media, we always have to tie it in with some form of online, for example, as I said, the QR codes we used, or the PDF format that is readable, for example, by a specialized reader. And these things is what would allow a wider range of people to use our prototype or flyer. I think that inclusive communication is needed and also because disabilities do not only mean something completely extreme. A disability can also be just seeing a bit poorly. For example, I have glasses, I see a bit poorly. Sometimes I feel like I need to have larger text for me to understand and to read something. So I think that inclusive communication encompasses a wide range of necessities that we still currently need.
Okay, thank you.
Thank you so much for such a wonderful presentation.
Yeah, I would like to thank you for the opportunity. I was really excited to do the presentation, and I hope that my points came across clearly.
Yes, very much. Thank you. Now, I would like to proceed by sincerely thanking our authors for their excellent presentations and valuable contributions to this session, and all of our participants for being a part of this international conference. I hope this session was informative and enriching for everyone. All the presenters will receive their digital certificates via email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the ICICT 2026 team. On behalf of the entire team, thank you for your continued support through the 11th edition and all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. Now, as a token of appreciation, I would like to present these certificates for our session chair on behalf of Team ICICT 2026, a global knowledge research foundation and partners. I would now like to invite Dr. Poonam Relkar to kindly deliver the closing remarks.
Thank you, Pranjal. Thank you, everyone, as being a part of this session at ICICT 2026. Today's papers clearly showed how technology is moving beyond the prediction toward the trust, transparencies, and the inclusion. So we saw the important discussions on explainable AI in medical imaging and ECG analysis, where confidence is a critical as an accuracy. Then the work on uncertainty quantification reminded us that reliable AI must communicate its level of confidence. And in the recommended systems, we explored how principles feature attributions can improve the transparencies in deep models. So the study on electric vehicles acceptance demonstrated how statistical methods can guide sustainable policy decisions. We also saw how universal design can make communications more accessible and socially responsible. So I appreciate the depth of the research and the thoughtful response from all the authors. Thank you for the presenters, audience, and the organizers. Thank you.
Thank you so much, ma'am. Now I would like to call upon Dr. Lakshmi to give her closing remarks.
Thank you. As we come to the end of the session, I would like to sincerely thank all our presenters for their excellent and insightful presentation. The topics discussed today were truly informative and thought-provoking. Questions and interactions added great value to the session and made the discussion more meaningful. On behalf of the organizing committee, I extend my gratitude to everyone for their time, attention, and contribution to making this session successful. Once again, congratulations to all the presenters for their hard work and dedication. Thank you all.
Thank you so much, ma'am. I would like to now extend my sincere thanks to our session chair for chairing this session with great energy and for their valuable presence and guidance throughout. Now, I would kindly request all of you to switch on your camera so we can take a quick snapshot of this virtual conference so that we can display these valuable memories on the conference website. Everybody, please switch on their videos. Okay. Everybody, give me a smile. Thank you so much, everyone. It was such an honor to have you all of you here. You may leave the meeting.